Hello everyone, welcome to my YouTube channel. This is part 5 of B Sharp in C Sharp tutorial series. In this series, we are going to learn about stack and heap. So stack and heap are types of memory available in the .NET framework, or you can say the object-oriented language C Sharp. So let's start with stack. In C Sharp, stack and heap are two types of memory used for storing the data. Understanding their differences is the key thing writing the efficient code. Okay, that means stack and heap, both of them are being used to store some kind of data into the memory. So these are two types of memory, and if you understand the difference between these two type of memory, it would be very beneficial for you guys to understand how to write the efficient code, how your application can work robustly, can perform robustly. Okay, so if you know about the key difference between these two, it would be very beneficial for your project. Okay, so let's talk about one by one. First of all, we are going to talk about the stack type of memory. Okay, so as name suggests, it is a kind of stack which is storing the values of value types. Okay, value types means there are several kind of data types which are value types which are going to store some kind of value. For an example, integer, float, decimal, double, bool, or struct. All these data types are uh, value types. Okay, the next is stack is going to contain or going to store the information all about the method calling information or the method execution. Whenever you have created a method, and if that method is going to be executed in your program, that information would be saved into the stack, means all the local variables whichever you have defined over there, right? And the method execution. Stack is again going to hold the reference to the object in the heap. Okay, I'll give you an example on this, how it is going to store the reference of the objects which is going to be saved into the heap. Okay, the key features of stack is it allocate and deallocate the memory automatically. Okay, so whenever we are going to assign some value to a particular variable of value type, the memory allocation would be automatically, it would assign a particular memory to that particular variable automatically, and once that value is being utilized in your code, it would just deallocate that particular memory. Okay, it follows last in and first out order. In general we call it LIFO. Okay, so let me give you an example. So see, stack, as the name suggests, it's a pile of books, right? So whenever like if you have a table, and on that particular table there are several books are here and there, and if you want to collect those books and create a pile of books, it would be like this. Okay, so it would be, there would be first book, and on the top of the first book you will place the another book, then another book, then the another book, and that is how it gets increased. Okay, so in the same manner the stack is going to work. Okay, so whenever you define a variable, let's suppose here I have defined int a equal to 10. Okay, so int is a kind of value type. Okay, so whenever I am going to define a variable of integer type or a value type, it would assign a particular memory to it. Okay, so how it would assign? First of all, it would let's suppose this stack is not here as of now, we are declaring the very first variable. So what it would do, in the stack memory, it would allocate one space to this particular variable. Okay, so it would save a equal to 10 here. Okay, now if we are defining some kind of bool, let's suppose b equal to true. So bool is again kind of value type, we are assigning some value, true or false value, so it is again a kind of value type. So what C# would do, it would assign another stack kind of memory to this variable b. So for this variable b, on top of variable a, it would create another allocation for variable b equal to true. Okay, now if we are defining any other variable, for an example decimal C equal to 10.50 m. Okay, so decimal is again a kind of value type, and for this variable C type of decimal in the stack, it would allocate another memory on top of the second memory. Okay, so it would assign C equal to 10.15. Okay, so it would get increased. Okay, so whenever you are going to read the value from this particular stack, first of all this value would be there last in, so the variable C is entered into this stack at the very last. So if we are inserting, or if we are like assigning some variables of value types, it would get saved into the stack, and the process is called push. Okay, when we are assigning some values and inserting some values into stack, the mechanism is called push. So we are pushing some value. Okay, we are inserting the value to an stack, that is called push mechanism. And if we are reading the value from this particular stack, if we are reading or we are accessing some values from this particular stack, that is called pop. So this stack basically works on these two principles, push and pop. Okay, so the key point is the stack basically works on last in first out mechanism, and under this mechanism it used two principles, push and pop. Push is basically to insert element into the stack, and pop is to access the elements from that particular stack. Okay, so all the value types would be get saved into the stack memory. It is not allocating the memory dynamically, that is why this stack is little bit faster, but it is limited in size. Okay, let me give you a practical example in C# how we can assign the variables or how we can push the values into the stack memory. So let's jump onto the Visual Studio. I have prepared one example for you. So here in this example, I have defined one integer type of variable age, and in this age I am assigning one value 50. The second variable is type of bool is active. Here I am assigning value as true. Then I have assigned three variables, decimal, double, and float, and here I have assigned these values. I'll tell you the difference between these two in the upcoming sessions, but all these three are the value types. Okay, so here I am just printing these values. Let me execute this program and I'll show you what would be the output, and after that we'll see how these values are being added into the stack. So we'll see, if we run this application, this would show us this output: age is 50, status true, price in decimal, double, and float. Okay, so let me stop this application and get back to one performance profiler which I have shown you into the garbage collector video. So at that time we understood how garbage collector works, but let me tell you here one thing: if the values are being assigned into the stack, those are not being handled by the garbage collector. Garbage collector can only handle the heap type of memory. Okay, I'll show you how it works. So what you need to do is, you first of all you need to change the mode here from debug to release, and you need to go to this debug tab. Under this debug tab you would find performance profiler. Okay, or what you can do is you can press alt F2. So you'll see this window here. You just need to check .NET object allocation tracking, click on start. Once this is started, your application would get executed. You will see the output, and once you see the output, you just stop this collection. So once you see this graph, what you need to do is you just need to select the area from where you just need the report to be generated. Select that particular area, click on this output button. It would generate the report for you. Okay, so here first the first tab you can see the inside tab. So inside tab you can clearly see no garbage collector inside found. Okay, so that means garbage collector did not get executed on the stack type of memory. Okay, so garbage collector would not be able to handle the stack type of memory. It only manages the heap type of memory. Come on to this uh, functions. So in the functions you would see your project name is there, CodeMasterBipin project. So if we open this project, you will see there are some type of memory allocation happen. Okay, so we had defined a decimal variable over there, then the double, a boolean, an integer, and a single variable. Single means a kind of float variable. Okay, so all these 5 variables I had defined over there, and the memory allocation happened over there. Okay, but there is no GC executed, and if you see the collection also, there is no GC occurred in the selected time span. Okay, so this memory got allocated for all these data types. It would not show you the allocations because it would just show the heap type of memory allocation over there. Okay, for the value types, it would not show you how much memory it took. It just tell you the size of that particular variable. Okay, so that is how you can validate how your value types are being stored, if any GC is being performed over there or not. Okay, so this is the example for value types. Let's jump on to our slide. The scope of the variable, the scope of the value type variable, or the like values stored into the stack memory, is that the value stay there into the stack memory for a limited time period. Okay, once your method is gets executed or your variables were assigned and you have consumed those variables into your functions, after the execution it would just release the memory from the stack. Okay, so the value types would remain there until you use them from the stack memory. Okay, so after that the value types would not be available. You would not be able to use those values from the stack memory. The same example I have given to you. I can give you another example also. Let's get back to Visual Studio again. Let's remove this code. I have prepared another example for you guys also. So in the second example, what we are going to do is we are going to create an struct also. Okay, so if you are defining an struct, let's suppose we have defined an struct of coordinate, and this struct is having two type of properties, x and y, x coordinate and y coordinate. So whenever I am going to assign this value to this struct, all these values are going to be saved into the stack memory. Okay, this is integer, this is y is also integer, and I'm going to print this. And if I run the same debug and performance profiler, it would execute my application, and you'll see there would be two things it would capture. Let's stop the collection and let's wait for it to generate the report. Once the report is generated or the graph is generated, you just need to select the area and click on this output button, and you'll see in the insight there is no GC insight found. In the collection also there is no GC found, but in the function you will see under the CodeMasterBipin we have defined two coordinates x and y type of integer. So here you can see for the type of integer it is assigning two allocations. Okay, but if we talk about the bytes, for one integer it takes 12 bytes, and if we are assigning two variables then it is taking 24 bytes. Okay, so here you can see these two integer values, it is assigned two allocations and size of 24 bytes. I hope this is clear to everyone. Now let's get back to our second type of memory, which is heap memory. So as I told you in our previous video tutorial of garbage collector also, heap is a type of memory which is responsible to store the reference type. A reference type means any kind of object, array, instance of any class, or a list, dictionary. All these kind of reference types are going to be stored into the heap memory. Or apart from this, all that kind of data which needs a dynamic memory allocation, you can say. Okay, all that type of data is going to be saved into the heap memory. Features, if we talk about the features, heap memory is basically allocated and managed by the garbage collector. I have already told you. This garbage collector basically allocates the memory and manage the memory by releasing the unused object in 3 stages. Okay, you can go through my garbage collector video tutorial. I'll provide you the link here, and you can watch it, and you can try to understand what is garbage collector, how it works. Heap type of memory basically larger in size and most suitable for the long-lived objects. Okay. So if there is an object having some kind of values, and that need to be used for a long time into your program, and it is having some kind of references also, so at that time you can make use of this heap memory, okay, using the reference type variables. As it is assigning the memory dynamically, so obviously it is going to be slower than the stack memory. The catch is, whenever we are going to, or whenever the C# language is going to assign a heap memory to a particular object or particular reference type, it works with the value type. Let me give you an example how it works. So in the heap memory, let's suppose this is the heap memory, the entire heap memory. Okay. This is, let's suppose this is 10 MB heap memory is there. Okay. If I have defined a string is a type of reference type. If I have defined a string n equal to RAM. Okay. So at this time, what would happen for this variable n? This variable n is a type of reference type. So what it would do is, in the stack, it would allocate one memory for this variable n. First of all, it would allocate one memory. Let's suppose this n is taking 1 MB. N is taking 1 MB of space. Okay. So what garbage collector would do is, it would allocate 1 MB memory to this particular variable n. It would assign a particular memory location. So let's suppose the memory location is 1001. Let's suppose this is the location of this particular memory. The 1 MB memory location is 1001. So what it would do is, in the stack, it would add this reference here. So whenever we are going to access the value of this n, first of all, it would go to this stack memory, find out the reference. Okay, what is the reference number, or the what is the memory location for this particular variable n equal to 1001. Okay. For this particular variable, what is the location number, memory location number, and based on this memory location number, it would find out the value. So here on the n, here on this 1 MB, the value would be saved as RAM. Value would be saved as RAM. And in the stack, it would hold the reference of that particular memory. Okay. For this 1 MB memory, there is a reference number or the memory location number 101. In the stack, this 101 would be saved against this particular variable. Whenever we are going to access that particular variable, first of all, it would check into the stack. Okay, if that particular variable available in the stack having a reference number, get the reference number, based on this reference number, find out the value. So that is how this heap memory works. Whenever we are going to assign a value to a reference type, first of all, it gets saved into the heap memory. There would be a memory allocation code or location ID kind of thing. That memory allocation ID would get saved into the stack along with that particular variable. Okay, I hope this is clear to everyone. This would be heap memory, and this is our heap memory. Heap memory would have the actual value with a ref number, and in the stack memory, it would hold the variable with ref number. Okay, it would save the ref number here. Based on this ref number, we can get the value from here. Heap is assigning the memory dynamically, so obviously it is going to be slower than the stack memory. If we talk about the scope of the values or the scope of the data, for how long the data is going to be exist in this particular memory, so it all depends on the garbage collector. If your reference type of object is not being used in the application, garbage collector would free that particular memory. Okay, so I told you there are three stages under the garbage collector: stage 0, stage 1, and stage 2. So you can watch the garbage collector related videos, and you would be having better understanding. Okay, so until and unless garbage collector free or dispose your objects, the data would be available into the heap memory. Let me give you an example of this heap memory. Let's go back to our Visual Studio. I prepared one example for you for this heap memory. First of all, we are going to create one class. Let's suppose I'm using the same class, same type of properties which I've used for struct. So I have created one class coordinates, and this class is having two properties having integer types, and one is string type. So if I am going to assign the values to x, y, and name, first of all I need to create an object of this particular class, right? So here I have created one object of this particular class. This is the object, and this is the instantiation of this particular class. Whenever I use a new keyword, it is going to create a new object, but the process is called instantiation. Okay, so this would be the object. Here I am assigning some values to its properties. X is 10, y is 20, name is Delhi. I am going to print these values. Okay, so this is a type of object, and it is going to be saved into the heap memory. Let me give you another example of heap memory type. So as you can see here, we have defined one string variable name, and we have assigned a value ram, and we are just printing it. Here we have like call the garbage collector to suppress the finalize method and collect all the generations and release the object. Okay, so once your report is ready, so you can see here in the allocations for this string, some allocations happened. In the call tree also you can see some allocation happen on this string. Okay, and on in the functions also you can see your project name is there, and under the project name you will see there is input record is there. Okay, so which is it is a program dot main method. Under this program dot main method some allocation happens. Okay, so if you go to the collection, so you will find in the generation garbage collector 1, the generation 2, the object was non-concurrent, and it assigned some kind of memory. Okay, and you can see this is a type of system dot string. In when we assigned a value of type like value type, it got saved into the stack, and this collection was not there. It was not showing the generations. All these information was not there because garbage collector handles all the reference types. So at that time you would see all these kind of collections and what at what generation that object is there. Okay, is it a part of generation 0, generation 1, or generation 2? If it is a long lived object, then it would be part of generation 2. If it is a kind of medium, it would be part of generation 1, and if it is a short term lived object, then it would be part of generation 0. So that is how you can validate where your based on your data type, where which kind of memory is being used into your program. Okay, let's go back to our slide. This is the example I've shown you. So the data exists until it is freed or disposed by the garbage collector. I'll tell you one more thing. Let's go back to our graph. So here, as I told you, let's suppose this is your heap memory. Okay, and you have assigned one value string a equal to ram. Okay, so whenever you are going to assign this particular memory, I told you that one memory would be allocated for this value. Okay, ram, let's suppose this is total 10 MB. Out of 10 MB, 1 MB is assigned to this particular value ram, and for this ram value under the stack it would assign a reference number 001. So for this particular memory, the reference number is 001. Let's suppose you have created one list and you have created an object of this list, new list. Okay, and you are assigning some values to it, obj dot add, and you are assigning a value to a, b, or c, like this. You are assigning the values into this list. So what it would do is, out of this 100 MB, let's suppose this list is taking 5 MB. Okay, so what it would do is, it would assign the 5 MB from this particular memory, but the reference number, it would be different. Okay, so let's suppose here it has defined the 5 MB memory to this particular list. Okay, and for this particular list, let's suppose the reference number is 2100. Okay, so what it would do is, in the stack it would say for obj equal to 2100 is assigned, so it would store the reference number 2100 into the stack, and whenever we are going to call this particular object, or we are going to get some values from this obj, so it would find the reference from the stack, go to the heap memory and find this location. Okay, this location number, and whatever value is written on this particular location, it would just return that. Okay, 1 MB is consumed here, 5 MB is consumed here. Now we are left with 4 MB. Okay, so now garbage collector comes into the picture to release the memory. I have told you all these scenarios into the garbage collector video. You can go through it. I'll attach the link here. Okay, so whenever garbage collector would come, it would check, okay, this memory is being consumed or not. If not, release it. If this memory is being consumed or not into the program, if it is being consumed, pass it to the next generation, otherwise just release it. And in the same process, it would like manage the entire this memory. Okay, so that is how these two types of memory is going to work. Okay, I hope this is clear to everyone. And if you are having any kind of question related to these two memory types in C#, please do let me know into the comment box. I would be very much happy to help you. And guys, if you have not subscribed this channel, I would request all of you to subscribe this channel, like the videos, and share it with your colleagues, friends, and the known who are working in the development profile and who want to learn the C# language. In the next topic, we are going to understand more about the data types. Under the data types, there are 3 types we are going to cover. One is value type, reference type, and then nullable types. So we are going to learn all these types in a very detailed manner with a practical example. That's it for today, guys. Thank you so much. Have a good day.